We're back, ready to talk about more absolute value stuff. So we're going to finish 1.9 today and look at some absolute value inequalities. And it'll be a great time. Hopefully you're excited. It says you can write absolute value inequalities as compound inequalities, and we talked about this in the last section. Okay, this is when you have two inequalities, basically. The graphs below show two absolute value inequalities. So the first one, we have absolute value of n minus 1 is less than 2. And as you can see, you have the open circles because it's less than. And it's shading in between here. So this is like an AND problem, because you're shading in between. Then you have the absolute value of n minus 1 is greater than 2. And you can see you have the open circles here, but they're shading away from each other. So this is like an OR problem. Okay, so if it's less than, it's an AND problem. If it's greater than, then it's an OR problem. Okay, and this represents all numbers with a distance from 1, so this is the number you're looking for, from 1, that are less than 2 units away. So n minus 1 means, absolute value of n minus 1 is less than 2 means that n minus 1 is between negative 2 and positive 2. Okay, so you're looking at the distance from the number 1, here's 1 right here, that is less than 2 units away, so everything in between here. This one is the same thing, it's the distance from 1 that is greater than 2 units away. So if we go 2 units away, and we're going to go greater than that, so it goes that way and that way, 2 units. Okay, so this is an OR problem, so n minus 1 is less than negative 2, or n minus 1 is greater than 2. Alright, so let's look at this one. This is what are the solutions of absolute value of 8n is greater than or equal to 24. So automatically you should be able to look at this and say this is an OR problem because it's greater than. Okay, but if you're not sure, if you get confused, you can always just go through and solve it like I'm about to right now. So absolute value of 8n, if I want to remove the absolute value, I have to write two equations, or two inequalities. So I'm going to say 8n, the first one stays the same, is greater than or equal to 24. Then I got to switch it, so the next one's going to be 8n, and I'm going to switch it to negative 24, but when I switch it to negative, just like when you divide by a negative, you have to flip the sign. So it's going to flip to a less than or equal to. Okay, and then just solve this by simply dividing by 8. So everything, and then I get n is greater than or equal to positive 3, and n is less than or equal to negative 3. Okay, and this is again is an AND problem. No, it's an OR problem, sorry. So if I want to graph that, I have my 0 here. We'll just say this is 3, this is negative 3. It's not really necessary to draw all the tick marks as long as you know where the numbers that you care about are, like 3 and negative 3. These are equal to, so I'm going to put a closed circle here. And this one says n is greater than positive 3, so it's going to shade to the right. This one says n is less than negative 3, so we're going to shade to the left. Okay, and it is an OR problem, so we're just going to leave it like that. So it's either this part or this part. Okay. Alright, I'm going to let you try this one, and I will do it as well. And we'll talk about it when we're done. You can pause this in 3, 2, 1, pause. Alright, so this is what I got. I have a greater than problem, so it's going to be an OR. So x is greater than 1/2, greater than or equal to 1/2, or x is less than or equal to negative 9/2, which is negative 4.5. So I first plot 1/2, which is here. And it's a filled in circle, and it goes to the right because it's greater than. And then negative 9/2, which is here, goes to the left because it's less than. And it's an OR problem, and they are going away from each other, so it's all good. Alright, moving on. Solving an absolute value inequality involving a less than or equal to. So this is a STEM problem. Manufacturing. A company makes boxes of crackers that should weigh 213 grams. A quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. What is the range of allowable weights for a box of crackers? Okay, so we have to set it up, which can kind of be tricky sometimes, but we know that we don't want it to vary by more than 5 grams. Okay, so that's going to be what's on the right side of our equation. So more than 5. So we want it to be, we don't want it to be more than 5. So we want it to be less than or equal to 5 grams. Okay, and we know that it should weigh 213. So our new weight, which we can just call W, subtract what it's supposed to weigh, 213, should be less than or equal to 5. Okay, and then I use the absolute values because it could be more than 13 and it could be less than 13. It doesn't matter. As long as it's within those 5 grams. Okay, so here's our equation. And then we can solve it. So I'm going to rewrite 2 new equations now. So W minus 213, I'm going to keep the first one the same, less than or equal to 5. And this is an AND problem now, because it's less than. And then we have, and W minus 213 is greater than or equal to negative 5. So we switch it to negative, and then we have to flip the sign. Okay, all right, and then we just solve. By adding 213, can do it at the same time, just for fun. Those will cancel, and I get W is less than or equal to 218, and W is greater than or equal to 208. So that tells me that W has to be between 208 and 218. So we can also write that as a compound inequality that looks like this. 208, let's use a different color. 208 is less than or equal to W is less than or equal to 218. Which again basically just says W is between 208 and 218 inclusive. If we wanted to graph that, we put 208 over here somewhere, 218 over here. They're filled in circles because it's equal to. Then we would shade anywhere in between. So it can, the box of cereal or whatever we're talking about, crackers, can weigh anywhere between 208 and 218, and that would be acceptable. Okay, if it weighs outside of that range, then the quality control inspector is going to be mad, and someone's probably going to get fired. But that's none of my business. So, all right. Okay, I'm gonna let you try this one. I'm talking about boxes of pasta now. See if you can set up the inequality, the absolute value inequality, and solve it. And I will do it as well, and we'll talk about it. So you can go ahead and pause this in 3, 2, 1, pause. All right, so I went ahead and solved this one. This one is a much smaller margin of error because it can only be 0.05. So W minus 32, because that's the way we want it to be. Absolute value of that is less than or equal to 0.05 because we don't want the error to be more than 0.05. And then we go ahead and solve that. So less than or equal to 0.05, and then greater than or equal to negative 0.05, and then you add 32 to both sides, and you end up with this. So W has to be between 31.95 and 32.05 grams or ounces or something. Ounces. Okay. I didn't graph this one, but again, you would just graph between the two, and it would be a closed circle. If we look at B here, this is in problem 5, which is the other weight one we did. Could you have solved this by first adding 213 to both sides? So going like this. And just adding, so instead of splitting it into 2 equations, just adding 213 here and saying absolute value of W is less than or equal to 218. Well, no, we can't do this because, first of all, you're just taking this out of the absolute value without any proper rules, following any proper rules. And then if we were to do this, this would be saying W is less than or equal to 218, so your weight could be less than 218, and then when we switch it, W is greater than or equal to negative 218. So that's a huge range there. So basically, if that were the case, your weight would be between negative 218 and positive 218, which is not very useful information, okay? Because first of all, you can't have negative weight. So yeah, that's why we can't add the 213 first. You have to set up the 2 equations because it gives you 2 totally different answers. Okay, so can't do that. You have to first set up the 2 equations and then add 213 because when you set up the next one, it makes that part negative and then it fixes the stuff that we just did there. Okay, so make sure you are, before you get rid of the stuff inside the absolute value, you have set up 2 equations. All right, so that finishes chapter 1. And make sure you do the Canvas quiz, and then we'll take a test at some point, in like a couple days. And yeah, hope you've enjoyed your first chapter of Mr. J's totally cool math vids, and we'll catch you all on the next one. All right, TTFN, see you guys later.